So, hello everyone. Welcome to this Men&Mice webinar. My name is Peter Pettersson, and today's webinar is focused on Kea, the new DHCP server from ISC. And with me is Karsten Strodman. Karsten, you are there?
I'm here.
Very good.
Hello.
So Karsten is from the Men&Mice services team, and he will be doing the presentation here today. So please note, everyone, that you are on mute, but we encourage you to submit questions through the GoToMeeting control panel. We are also recording this session, and you can find this webinar along with the slides at our website within a few days. At our website, you can also find recordings and slides from our previous webinars. And if you drop off this call, you can at any time go to our website and for seeing the rest of the recording there. So, Karsten, the audience is yours.
Thank you, Peter. Do you see my screen sharing? Do you see the slides?
Let's see. No, I don't see it. Yeah, there it is. Yeah.
Okay. Very good. So, hello everybody. This is Karsten from Men&Mice, and this is today the webinar on the new Kea DHCP server. So what is this? Kea DHCP is the successor of the ISC DHCP. And the ISC DHCP server has been the standard DHCP server in the Unix world for the last 20 years, or almost 20 years. It started in 1997. And it is available, the old one, in Linux, or for Linux, for the BSDs, for Mac OS X, and commercial Unix flavors like Solaris. And it has been widely seen as the reference implementation of the DHCP, of the dynamic host configuration protocol, and it's also the base of many DHCP offerings out there. So the history of the old ISC DHCP, the old faithful ISC DHCP, is that the story started in 1997, which was the same year that the RFC 2131 was published, which is the RFC that defines DHCP v4 as we use it today. Over the years, there has been new versions like version 2, version 3, version 4, and version 433. Patch 1 is the one that is currently out and it's using. But now there's something new, because the internet has changed and our networks has changed since 1997. The number of machines in the networks grow drastically, especially with wireless networks and smartphones and tablets and all these bring your own device machines coming now to the networks, and that changed the landscape compared to 1997. Also, dynamic DNS update has been added. Mass provisioning requests are there. DHCP v6 is now coming into play, and DHCP is not only used to deliver IP addresses to client machines, it's also used for provisioning, like for the voice over IP phones, to deliver configuration strings to the voice over IP devices. And the ISC DHCP server has shown some weaknesses over the time. First of all, the code is quite old and it's not as fast as it could be, especially on modern machines. When ISC DHCP was first designed, single core machines were the norm, and nowadays we have multi-cores. And ISC DHCP it's just not scaling good on these new machines. It has a rather complex configuration language, which is welcomed by some because it is very flexible, but it is very hard for newcomers in the game, like administrators that set up a DHCP server first time. DHCP v4 and DHCP v6 are separate servers with their own separate configuration file, separate lease file, all that, and there's no built-in statistics, and as I said, it doesn't scale with modern hardware as it should be. So the solution is Kea DHCP, which is a brand new product. It's not an upgrade to ISC DHCP. It's actually a completely new designed piece of software. It started in 2011 as part of the Bind 10 project. At that point of time, there was a DHCP module within Bind 10. Unfortunately, Bind 10 had to be stopped in 2013, but the DHCP module survived that project and lives on now as Kea DHCP. And last December, we have seen the very first general availability release version 1.0.0, something that is now ready for production. So what is Kea DHCP? Now it is a DHCP server for v4 and v6. It has a combined configuration file, and it also has a combined storage. At least it could be used that way. So it's not as separate as the ISC DHCP. It's much faster with a regular SQL database backend, with MySQL backend. We have seen 1,000 leases per second given out. Even could be faster with the in-memory database that is available there, and also with some tweaking of the database level, it could be faster. But even 1,000 leases per second is surpassing much the old ISC DHCP, which is with much luck you could get it to some hundreds of leases per second, but not thousands of leases. It currently supports failover configuration via the database level. I will come back to that later. It has host reservations where you can put in the Ethernet hardware addresses, the MAC addresses, and give out the same IPv4 addresses for the same machine. You could do that same for DHCP v6 with either the DUID of the client or also the MAC address. It supports PXE booting, prefix delegation for IPv6. It has dynamic reconfiguration, so no need to stop and restart the daemon processes. Instead, you just send the new configuration over to the running daemon, and it will reconfigure immediately in memory. It supports dynamic DNS updates and does that much better than the old ISC DHCP without creating any bottlenecks. And there's a SQL database backend. Currently supported is MySQL and PostgreSQL, but because it's a pluggable architecture, there could be other SQL databases or even other storage backends later on. It has a built-in statistics module, which gives nice statistics like how many leases are given out, how many requests it has been seen, and so on. And it's licensed with an open source license. It's the MPL, the Mozilla Public license. So it's open source and can be found as source code on the ISC FTP server or on the Kea homepage, which is kea.isc.org. Kea is already available in version 1.0.0 in several Unix distributions. It's available in CentOS 7 and Red Hat Enterprise 7 as in the so-called EPL package repositories. That's extra packages for Enterprise Linux. It's in Debian Unstable, that is the upcoming Debian version. It's in Fedora Linux in the current Fedora 23. It's in Arch Linux, and it compiles on FreeBSD and Mac OS X. So I prepared a demo to show you a little bit how Kea looks like, how it is being configured, and I did that on CentOS 7. And installing Kea on CentOS 7 is quite easy. Just 2 commands. You install EPL release and then you install Kea, and you're ready to go. So my demo setup here is 3 machines. I have a DHCP client, and for the client part, I'm using the client from the ISC DHCP part. Note that Kea is only the server part. There's no DHCP relay agent in Kea or a client part. So for relay agent work or client part, you still have to use the ISC DHCP. And then in the center, I have Kea DHCP, and we start with IPv4 DHCP. And I have a separate database server which is running PostgreSQL as the database layer. So the ISC DHCP client will send a DHCP request to the server. The server will find a free IP address list, store that in the database, and then give the information back to the client. So let's have a look how that works. So I have a recorded video of the demo. So when we start, there's no Kea processes running. And I check that the Kea module is actually installed, and it is. It's Kea 0.1.0.0. And the configuration file lives in etc kea.conf. And the configuration file is actually JSON, which is JavaScript object notation, which is a subset of the JavaScript programming language. So here in the configuration, it is configured to listen on the interface enp0sh, sorry. And this is the database configuration. It goes to a PostgreSQL database. The database name is Kea DHCP, and it lives on the IP address 191 in my network. And we have just one subnet configured with a pool, and the pool gives out IP addresses from 192.0.2.1 to 200. And then we have some logging configuration in here. So that's the whole configuration. Because it's JSON, it really helps if you have a text editor that knows a little bit about JavaScript. Emacs works fine, Vim works fine, because of all the curly braces and the other quotations. It helps to balance out that. So I've created systemd service units here for Kea. So I've started the Kea DHCP and checking the status. It's currently active running. So there was no problem in the configuration. With systemctl-l for long status, I can see all the log output from Kea while it was starting. So we see here that the DHCP server was starting. It's listening on the configured interface. And it has found a new subnet configuration with a valid lifetime for 4,000 seconds. And it made a successful connection to the PostgreSQL database running on the other server. And it is now completely started with dynamic DNS is disabled for the moment. So now I'm starting a TCP dump on the DHCP server machine. So just that we see the conversation between the client and the server. And that yellow window here is my login to the client machine. And I'm just rebooting the client because on reboot it will just request a new lease. And we will see that communication between the client and the DHCP server here in the TCP dump. And later on I will have a look in the lease database. And here we see the communication coming in. The client is sending a DHCP discover. That was the first message where Kea is responding to the client saying, hi, I'm a DHCP server, I have an IP address for you and a configuration. The client is requesting that IP address. It was given by Kea, and then the client is confirming, or better, Kea is confirming that the lease is given out. Kea comes with a handy script called Kea admin. Kea admin, among other things, can be used to dump the lease database. And here I'm dumping from PostgreSQL. I'm giving the username, password, name of the database. -4 is for the IPv4 database. The output file is lease.dump. It wants me that the file already exists. Asks me if I want to still continue. And this is the content of the lease database when dumped out. And it's in comma separate value format, one lease per line. so it can be easily imported into LibreOffice or Excel or similar spreadsheet formats. Of course, the database itself lives in an SQL database, and you can also go into the SQL database, inspect it there, and you can also make changes to the lease database or even the host reservations directly in the database. So that was the demo of the v4 part, and now we are expanding the demo to show IPv6 DHCP. And for IPv6 DHCP, I made a different configuration just to show what's possible. Instead of going to an external SQL database, I am storing the leases in a local, so-called a memfile database. The memfile database is very similar to the way how ISC DHCP is storing the leases. So it keeps all the leases in in memory, and then writes out to a text file all the leases given out. So let's have a look how that looks like. So when I start, it's only the DHCP v4 Kea running at the moment. And I'm now opening the configuration file again. And we will have a look at the IPv6 configuration. And this is the IPv6 configuration. It has an interface configuration. It's listening on the same interface as the v4 server. And the database configuration is of type memfile. Persist is true, meaning that all the leases that are handed out from the memfile are also written to a text file. And the name of the text file is given here. It's in the etc Kea directory. These are the global options configured, which is the lease lifetime. And we have one IPv6 subnet, which is the /64, and from there it's the /80 pool, where we give out addresses from requests coming on the interface ENP08. And then we have logging for the DHCP-v6 part as well, going to var log Kea minus DHCP-v6. I'm starting the Kea DHCP-v6 with systemd, checking the status if it has been started correctly. And here we have the startup messages. It's listening on the configured interface. That looks good. It has a new subnet with the preferred lifetime of 3,000 seconds and a valid lifetime of 4,000 seconds. The database file is etc Kea DHCP6.leases, and it's a memfile database. And the server has complete configuration. And at the end, it prints out the server DUID and the file name where the server DUID is stored. Now I'm switching over to the client, and I'm using the dclient command -6 for IPv6 -v to give us some verbose output, and I'm sending the request on ENP0S8 interface. And here we see the communication between the client and the Kea server, and the Kea server has given out the IP address 2001 db8:1::, and the client is requesting that address and is now able to use that address. Going back to the Kea DHCP server, we now have a look at the in-memory database, or the persistent part of that database, and that is also in comma separate value format. It's the same mechanism as with ISC DHCP. It always appends to the file, and there is a garbage collection process that is started or can be started every few minutes or so that can clean up the file. But new leases are always written to the end, so every lease can be appearing multiple times here. And at the end of the file, we're seeing the lease that has been given out to the DHCP client just a moment ago. So, and that was DHCP 6. And now I'm adding a dynamic DNS configuration to the game. There's an extra process called Kea DHCP DDNS that is there to update dynamic DNS zones with either A records and quad A records for forward zones or pointer records for the reverse zones for every lease that is given out. So in our case, whenever the Kea DHCP v4 server is giving out a lease, it will give a notice to the Kea DDNS process that is running on the same machine, and that is talking to a local bind server, which is in my demo setup also running on the same machine, but could be on a different machine. And that bind server will host the master zone files and will automatically update both the forward and the reverse zone. And I have a recorded video for that as well. So we now have the DHCP v4 and the DHCP v6 processes running. And I've expanded the Kea configuration. First, I'm switching here to JavaScript mode because it's a little bit easier for the eyes. And the DHCP v4 configuration now has an extra block for the DHCP DDNS. It enables updates. It overrides no update, meaning that if a client is not requesting any dynamic DNS updates, the server should ignore that and should make the update anyway. And there was the generic name, that is the name of the zone that should be expanded to the host name if the server, or sorry, if the client is not sending any host name. So dynamically created host names. A little bit down of the configuration file, we have the configuration for the DHCP DDNS process. The forward zones and the reverse zones are given here, name of the zones, IP addresses and host names of the DNS servers and port of the DNS server. Here, the DNS server is bind 9 running on the loopback address. So we have a look at the bind 9 configuration. And we have just simply one forward zone, one reverse zone here, and we do allow update localhost. In production environment, it's highly recommended to use TSIG for security, and Kea supports TSIG keys. For ease of use here, for the demo, I've just used access control by IP address. Now, after making this change, we have to restart. But first we have a look on one of the zone files. This is the forward zone file, and currently there's no client host in there. It's just the SOA record, NS record, and that's it. Starting the bind name server and checking the status of the bind name server. It's started correctly. Then I need to restart the DHCP v4 module of Kea, because we made changes there, and I need to start the Kea DHCP DDNS process, which gets the job from the DHCP v4 module, and the DHCP DDNS module then will talk to the bind name server. Checking the status of that module, it's active running, no error messages are shown in the log files. That's a good sign. Everything seems to work. Now I'm using journal control, which is part of systemd, to look at the log output of named with the -f following. So it will, like a tail -f, just print out the information. I've rebooted the client. The client will now restart and request a new lease. And now the new lease should be reflected in DNS. So we should see dynamic updates coming in to the bind name server. And here we are. We're seeing that a client, which is actually Kea, coming from the loopback interface, is updating the example.com zone, adding a resource record for an A record and a DHCP ID record there. And we see also updates for the reverse zone. I'm syncing the zone files to the disk and looking at the example.com zone, and here we see one entry for DHCP-client, which is the host name of my client machine, .example.com, the A record reflecting the lease that has been given out, 192.0.2.2, and the DHC ID, which is the cryptographic hash of the ownership proof of that client for this entry. And that was Kea with dynamic DNS enabled. So currently, Kea does not support the ISC DHCP failover protocol. Support for that is planned in the future release, but that does not mean that there is currently no option for high availability, because there is, and actually there's a quite good option for doing high available setups, because high availability with Kea can be implemented on the database level. And here is how that can be done. So this is a small example, an SMB, a small and medium business example. We have the client sending the request to a DHCP relay, which is usually a router with some IP helpers configured. IP helpers are sending the request simultaneously to two machines, where one is active and is a Kea DHCP server in active mode. Below there's another Kea DHCP server with exactly the same configuration. It can be just a cloned virtual machine, for example, which is in passive mode, meaning that it is currently not started. And there is a heartbeat going on between these two machines, which can be implemented on Linux, for example, with Pacemaker, which makes sure that just one instance is up and running at all times. And if the active version is failing, it then automatically starts the passive backup machine. And behind that, we have a database, a MySQL or MariaDB, also in active passive mode. So there's always one Kea DHCP server up and running, and always one database up and running, and if one machine fails, the other machine takes over. That is a relatively simple setup and easy to do, but it does not scale as easy as the next setup, which is a little bit more complex, but for the added benefit that it scales better for large enterprises. And here we have on the left side the DHCP client sending request again to an IP helper router that is sending to the Kea. Kea is again in active passive mode, and Kea is talking to a SQL database, but actually it's not talking directly to the database, but it's talking to a database load balancer, which could be MaxScale, which is an open source part of MariaDB. And this MaxScale looks to the Kea DHCP server as if it would be like a normal database, but it has actually the intelligence that there is a cluster of databases in the backend, which is the last line here, which is a MySQL or MariaDB cluster, and each cluster synchronizing with each other, and the load balancer is then distributing requests to the database to the different cluster nodes. Also, the MaxScale load balancer is also configured in a high availability setup with virtual IP. So there are more than one machine, and if one machine fails, the virtual IP is automatically failing over to another machine. And then there is GUI management. Men&Mice is very happy about this new Kea DHCP server, and immediately when Kea version 1.0 came out, our developers started implementing support for Kea in the Men&Mice suite, and it's actually coming along quite well. We were able to demo the first version of that support for Kea DHCP on Cisco Live a few weeks ago in Berlin. And here are some screenshots. And actually these screenshots are not so much exciting, because Kea DHCP support looks like exactly like the other DHCP servers we support. It looks the very same way as the ISC DHCP support or Cisco DHCP or Microsoft DHCP support, which is actually a good thing because as an administrator, you don't need to learn new things. It just works as before, just that you exchange the DHCP engines at the back end. Kea DHCP will be officially supported with Men&Mice Suite 7.2, which is planned for release in May this year. And that version will have special migration support for ISC DHCP and Kea DHCP. And it can be used to painlessly migrate an old ISC DHCP instance to a new Kea DHCP instance. And this works by installing the new Kea DHCP server, then installing the Men&Mice Kea DHCP server controller on that machine, add the new server to the Men&Mice suite, and then you see all the existing IP subnets or scopes on the ISC DHCP servers. You see the empty Kea DHCP server. You select one or more scopes on the old server and select migrate scopes, and then the subnets will be moved from the old server to the new server, including all the options, and if you like, also including all the active leases. So all you need to do is then change the IP helpers in your routers, point to the new server, and you are done. The old subnet on the ISC DHCP will be left disabled, but the data is still there. So if you need to go back for whatever reason, you can do that with a click from the GUI interface. And here is screenshots on that migrate scope functionality. So you select one or more scopes on the existing servers, which could be ISC DHCP, but can be any supported DHCP server in the Men&Mice suite. You select the destination server and then what should happen to the new scope and the old scope, and whether the leases should be migrated from the active server to the new server as well. And we have a new training on the Kea DHCP. It's a 2-day training with a lot of hands-on. We talk about installing Kea DHCP. We go over the configuration with IPv4, with dynamic pools. We do host reservations. We do both host reservations in the config file and host reservations in the database. How to define DHCP options, both the standard options and your own options for like your voice over IP phone infrastructure. We implement the test PXE booting from Kea DHCP, and then we have an introduction to DHCP v6 protocol, because not every admin has worked with DHCP v6. We talk about the differences to IPv4, and then we have some examples on configuring Kea DHCP for IPv6. We have the high availability options, and we will in the training set up an active-passive failover situation with a MySQL database there, and we also talk about troubleshooting, best practice tools, and how to get statistics from Kea DHCP, and maybe some scripts or even graphical tools to make them visible graphically. This training will be available in Europe, in Amsterdam, in August. And then in October, we have 2 dates, one on West Coast and the other one on the East Coast in US. And in November, we are back in Amsterdam again. As I say, it's 2 days hands-on trainings, and it's $1,795 US. And also in Q3, we will have a new certification test, which is the Kea Certified DHCP Administrator, KCDA. And every attendee of the trainings this year will have one certification test free. And that certification can either be taken at the end of the 2-day training or any time after the training. And that concludes my introduction and overview of the new Kea DHCP server. And do we have any questions?
Well, Carsten, thank you. Yes, we have some questions. So guys, for anyone on the call, you can submit the questions through the GoToMeeting control panel. But First question here, is it possible to integrate Men&Mice IPAM for dynamic updates?
Yes, of course. In the demo I've showed with the bind server, it's possible to use that with Men&Mice IPAM as well. So have Kea DHCP running under Men&Mice IPAM, have the bind running under Men&Mice IPAM, and Kea will then automatically do the dynamic updates, as well as dynamic updates can also be done from the GUI interface as well.
Okay. So Carsten, the new Kea server, how will that affect the lifetime of the old ISC DHCP?
Yeah, there's currently no end of life date being communicated for the ISC DHCP, but we expect that ISC will publish an end of life for ISC DHCP this year. This means that not that ISC DHCP will be end of life this year, but it means that the end of life date will be announced maybe this year, hopefully this year, and it will probably a few years in the future. So customers that are running ISC DHCP don't need to rush to upgrade to Kea DHCP, although it has some benefits if you upgrade, performance, more functionality. But there will be multiple years where you can prepare your migration to Kea DHCP. Just stay tuned, look at the ISC website, it will be announced there, it will be also announced on the DHCP mailing list, and probably we will cover that also on the Men&Mice website and send that out to our support customers.
Very good. The current version of the Kea DHCP seems to be ready for the regular corporate network, or are there any obvious shortcomings, Carsten?
Yeah, there are some shortcomings. One is that the error reporting is currently a little bit weak, so there's currently no tool to check the configuration before starting the server. This has been worked on. So currently it is the way that you have to start the server and then check the log output in syslog or journal control whether there's any errors in there. Then the failover protocol, some administrators really would like to see and use that instead of a database failover. And then there might be some special configurations, complex configurations that cannot be moved one by one. One that I could imagine is a specific client classification that has been programmed into the ISC DHCP, which cannot be reflected one-to-one in Kea DHCP configuration. Having said that, Kea DHCP has a series of hooks where you can, or ISC can, or anyone can hook in custom code in form of a custom ISC library, and that code will then be hooking into several parts of the workflow when a lease is given out, and the operation of Kea can be influenced from that library. So you can do almost anything with the hooks. Currently, it requires a little bit of C programming, but at least it is possible, and there will probably be easier feature of ways to do that later on, maybe in a kind of a scripting language.
Very good. So Carsten, here's a question. How far will a single DHCP server scale in both configured leases and active leases?
I don't have actually done my own tests here. So I need to pass on that question. I just haven't had the time to really max it out. So I did some tests with a few thousand leases, but I would guess that because Kea DHCP is running, if it runs against a database backend, it will just scale into the millions, because just modern SQL databases have no problems in working with these large data sets. And but I need to do my tests myself and to report on that, so I cannot authoritatively answer that question at the moment.
Very good. So you see, next question here. How many returning clients per second will it scale to?
There have been some tests with the SQL database. It could, with returning clients, could do without any special tuning 1,000 per second, and with the in-memory database, which is basically the max performance of the DHCP server itself, it was about 7,000 requests per second or clients per second.
That sounds impressive.
It's much more than the old ISC DHCP, which was more in the hundreds per second.
Yeah, exactly. Yeah. Very good. So, Carsten, I don't see further questions here.
And for people who want to do some benchmarking of Kea comes with a tool called Perf DHCP, which is a performance benchmarking tool, which can be configured to just send least requests as fast as possible to a given DHCP server, and then print out statistics on how many packets gets lost, how many answers it got, and so on. So if you set up a Kea DHCP server and you want to just do some benchmarking tests there, it's a handy tool. It's also a very modern tool, more modern than other tools that have been around in the internet, and that can be used to performance test Kea, can also be used to test any other DHCP server out there.
Very good. So, Carsten, if there are no further questions from this audience, I think we just put an end to this webinar now, unless you want to add any further information to the call.
Just if anyone is planning to migrate to Kea DHCP, we are happy to help, and also ISC is happy to help with that as well. And please, we would also be interested in getting your feedback there. It's a new product. There's probably stuff that can be improved. ISC would like to hear feedback. Men&Mice would like to hear feedback as well, and we talk to ISC about that. So yes, let's make this good product even better.
Excellent. Thank you very much, Carsten. Thank you, everyone attending as well. And once we will soon have a recording of this webinar available through our website as well. So thank you, everyone, and have a nice day.
Thank you. See you next time. Bye.